it's Matt Bernardin, the Vice President of the Stevens Game Development Club, and today I will be showing you how to use Godot and just how to make a simple first project in Godot. First things first, you're going to want to find the latest download for Godot of your operating system, which you can do at godotengine.org, and then also download this asset pack. It's the one we will be using for the game. Link can be found in the description. This is from Brackeys, which is what this tutorial is going to be based on. However, I will be modifying his tutorial, adding some things, taking away some things, just to give you guys what I think is the best learning experience. Once you download Godot, you're going to want to launch it, and then you're going to find this create button in the top left corner. You're going to want to use that to create. And you can name your project whatever you want. We're going to say tutorial. And then you can save that wherever you want as well. Now here you're going to see three options of the renderer to use. Forward plus is going to be like if you want to use more 3D graphics and you want it to be run just like as an executable on your desktop. Mobile, of course, if you want to do a mobile game, or compatibility if you want like to upload to the web, like have a browser game. And we are going to be doing that, so I'm going to select compatibility, and then I'm going to hit create and edit. I will note that because I am on a Mac right now, the buttons are switched on Mac compared to on Windows, so whenever you see buttons laid out left to right, they're going to be in reverse order on Mac for some reason. We're going to hit create and edit, and that will bring us into our project. And it's not going to look like much right now, but soon we're going to start making a game in here. This main window in the middle here is where most of the action is going to happen. This is where you're going to be designing your level. This is also where you're going to be coding. In the top left up here is going to be your node tree. So in Godot, every object is going to be a node, and you're going to have a list of nodes over here representing levels and characters, and we'll get into all that. Down here is going to be your file structure. So right now all we have is this default icon, but we're going to be adding our assets in a second. And then over here is the inspector window. So whenever you're hovering over a node, all the properties of the node will show up in this area. Again, this will all make sense in a bit. Navigate to the folder where you have your game file, and then you're also going to find the assets that I had you download earlier, and we're going to make a few folders in here. The first one is going to be for that assets, so I'll just name it assets. Then we're also going to make a folder called scenes, and we're going to make a folder called scripts. Now let's clean that up. And now into the scenes and scripts we'll leave blank for now, but we'll drag all of these into the assets folder. So you should see that those folders have appeared here in our file structure, and under assets you can find everything that we just imported. Before we start getting into anything is adjust some of the default project settings. So you're going to go up here to the project tab in the top, and then project settings. And the first thing we're going to change is the window size. So down here on window, we're just going to change this to 1280 by 720, just to give us a bit more room. We're also going to scroll down here a bit, and under stretch mode, we're going to change this to canvas item. That will allow the user to stretch the screen to whatever size they want, depending on their monitor, and then keep the aspect on keep, because we want to keep the same aspect. Towards the bottom, you're going to see a tab called layer names, and under that, you're going to see 2D physics. This won't make too much sense right now, but we're just going to change this now because it will make it much easier in the long run. We're going to change layer 1 name to player. We're going to change layer 2 name to world. We're going to change layer 3 to enemy, and layer 4 to items. We'll get back to this later. It'll make more sense later. Then we can close out of that. And now we're going to make our first node. So we're going to go over here to 2D scene. We're going to create a 2D scene. And this is our level. It doesn't look like much right now, but that's okay. We'll add a bunch more to it. This node 2D, we're going to change its name by double clicking on it and just call it level 1. But we don't have anything to put into level 1 yet. We want to make a player, but we don't want to just add the player directly to level 1 because we want to use that player in multiple levels. So it's something that we want to create as its own node. So we're going to save that. You can do Control S to save, and we're going to save this under the scenes folder. Call it, just leave the name as is, level1.tscn. We'll hit save. And now we're going to jump right into making a player. So we're going to hit this plus to make a new scene. And you see here we have the three default options, 2D scene, 3D scene user interface, but there's so many other nodes here and so many other nodes hidden in drop menus. There's quite a lot to get into, but right now we want a player, and a player is going to be a character body 2D. You can find it under this node path, or you can just search for character body 2D. And immediately we're going to get a warning saying that the node has no shape, meaning it doesn't know what the bounds of this character are. So what we're going to do is we're going to hit this plus again, and now we're going to make a property of this character body being the collision layer. So and it's called collision shape 2D. We're going to hit create, and now as you see, this tree structure is starting to grow where this collision shape is a child of the character body. Getting another warning that the collision shape doesn't actually yet have a shape. We haven't defined what that shape is yet, but we don't have our sprite in, so we don't actually know what to make that shape yet. So before we do that, we're going to click back on our character body, and before we go any further, let's rename it to player. And then under, as a child of the player, not as a child of the collision shape, we want to add the texture for our player, and that's called a sprite. And it's actually going to be an animated sprite 2D because we don't want our character to be static. We want it to have animations when it's moving around and stuff. So we'll hit create for animated sprite, and we're getting another warning that we haven't actually defined the sprite frames for this animated sprite. So we're going to go over here to this inspector window, and under animation, we're going to click on this empty where it says sprite frames, and we're going to say new sprite frames. Then we're going to once again click on that spot where it says sprite frame, and now we'll bring up the sprite frames tab from the bottom here. What we're going to then do is go to this button here, which is add frames from a sprite sheet. If you are importing a sprite that has all the different animations in their own separate files, then you would use this button here to add from a file, but we're using a sprite sheet in this case, so we're going to click here. We're going to go into our assets, into our sprites, and we're going to find our player, which is night.png. We're going to open that. And this will show us what we're working with here, but it's not exactly laid out correctly, where if I want this up here, I'm selecting this entire block. And so instead, we're going to change it to be an 8x8 grid. And as you see now, each individual sprite is in its own grid. And what we're going to do is we're going to first add this idle animation by clicking 1, 2, 3, 4 to add those 4 frames. And then we're going to rename this animation to idle. And then we're going to add another one by hitting this button right here. We're going to call this one run. And we're going to use the same button to add from sprite sheet. Click the night again. It's still set to 8x8. And we're going to use all of these. So you can click and drag to grab all of these as part of the run animation. And we're going to add those 16 frames. Make sure they are in the correct order. Now, if you zoom in, you're going to notice that while down here our sprite looks fine, in the game itself, it looks very blurry. And that's just a default setting of Godot called texture smoothing. And that's not something we want when we're working with pixel art. So we're going to go to project settings. And we're going to go to textures, so you can search for it up here. Textures. And right at the top here where it says linear, you're going to want to change that to nearest. And then close. And now you can see our sprite is all fixed up. If we hit this play button here, you can see it will play the animation, but it's going a little slow right now. So we're going to change this speed value here of how many frames per second it's running at. We're going to change that to 10. And double it, and that's much faster now. We're going to do the same with idle, change it to 10. What we're going to do is we're going to drag this sprite up so that it's sitting on this x-axis here. So what we're going to do is if you use this tool up here to move it, it will kind of just move in 3D space. We just want to move it straight up, so if we hold down shift when we move it, it will only move along one axis, and that will allow us to nicely snap it to that grid there. Then we're going to go back to our collision shape, and players are typically represented by spherical or pill-shaped collision boxes. So in this case, we're going to use a circle, and then we're going to drag this up so that it's kind of center with the player. Maybe shrink it down 1 or 2. Kind of get it to where it looks nice. And as you can see, our collision is behind the sprite right now. So in order to see it better, if we go over here and we drag it below the animated sprite, not make it a child of the animated sprite, but make sure it's still a child of the player just below the animated sprite, now it will appear in front, and that can give us a little bit more easier way of seeing the collision layer itself. This is a property of Godot where things are drawn top to bottom. So things closer to the bottom of the tree will be drawn last, meaning that they show up in front of other things. This animated sprite is being drawn first, then the collision layer is being drawn, so it appears in front of it. Continuing on with the collision, if you click on the player node, and then you go over here and drop down this collision thing, you'll see two different things, collision layer and collision mask. And if you hover over them, you'll notice that they're named the things that we named them earlier, like player, enemy, world, and items. So the collision layer is what that object is, basically, and collision mask is what do you want it to interact with. And so this first one's correct, it is a player, so we want the layer to be player. And mask, we don't want the player to interact with other players, but we do want the player to be able to interact with the world, with enemies, and with items. So the layer is 1, and the mask is 2, 3, and 4. Next, we're going to save the scene. Again, make sure you're in your scenes folder and hit save. And we're going to add this player to level 1. So what we're going to do is we're going to go to level 1, and we're going to find the player in our scene tree. Down here is scenes. We're going to take player.tscn and we're going to drag it right onto level 1. And that will place it in. If we zoom in, you'll now see that player is now a child of level 1. But if we were to run this, we wouldn't see anything because there's no camera yet. So as a child of level 1, we're going to add a camera 2D. We're going to make sure that it's centered on the player, which it almost is. You can see this pink box if you zoom out a bit. This pink box is the camera itself, and we're going to just drag it up a few pixels to make sure it's centered on our player. And we're also going to zoom it in. So we have two options here. We could make the player bigger, or we could make the camera smaller. In this case, because all of our assets are going to be at this scale, it makes sense to make the camera smaller. So we're going to go to here, it's right at the top, zoom, and we're going to set the zoom for both X and Y to 4. They should be linked, so just change one of them to 4 and they'll both change. And this is a much more reasonable camera zoom. If we want to actually run this like as a game, you have these buttons at the top here. This one is just running the current scene. It's a Command R on Mac, or it's F6, I believe, on Windows. Or you could just run the game, which is F5 on Windows and Command B on Mac. If you were to do that, it's going to say that there's no default scene or main scene yet. For now, we're just going to select current. That basically means that when you have like a title screen or something like that, you want to set that as your main scene so that when players load into the game, that's the first thing they see. And this is our game right now. It's a whole lot of nothing besides the player in the middle. We can't control him anyway because we haven't added a script yet. And that's what we're going to be doing now. So we're going to go back to this player at the top here. And with the player selected, you're going to select this add script button. This is going to ask us if we want to use this template for 2D character movement, which is what we do want to do. And it's going to tell us where we want to store this. We actually don't want it in the scenes folder though. We want it in the scripts folder. So we're going to select that. And then we're going to hit create. And this is going to be our first script. It's going to look a little overwhelming at first, but don't worry, we don't need to worry about it too much. Just make sure you save. And we're going to go back to level 1. And because we just added a script that had some gravity, that means that the player will now fall, and we don't want that to happen. So we need to add some kind of platform for the player to stand on. So with level 1 selected, you're going to hit create, and you're going to look up the term body. There's going to be a few different kinds of bodies here: static body, character body, and rigid body. Static body is going to be anything that you don't want to move. Think of like a floor or a wall or something. Character body is kind of self-explanatory. It's some kind of character, enemy, thing that moves a lot. Rigid body is going to be something like a pushable block, a block that can move but still has like a defined shape to it. Because we want a floor, we're going to select static body and hit create. I'm going to get a similar error to what we had before where it has no shape. So under the static body, we still need to give it a collision shape. So we're going to add collision shape. Then again, we're going to get a warning saying we haven't defined what shape we want. So over here in the shape menu, we have a bunch of different things. Earlier we used the circle one. You might think we use a rectangle here, but actually there's this one at the top here called a world boundary. And that's kind of what we're looking for right now. It's basically going to be this infinite plane that the player cannot pass through. It looks like it's this defined size, but it actually goes on infinitely. And this arrow is going to tell you what side you kind of want the player to be on. So it's pointing up, which is good. And we'll just leave it like this, move it down so it's kind of towards the bottom of the camera. We need to actually define this collision shape. So on static body, we're going to go to collision. And it's saying right now that it's a player and it interacts with other players, which is of course not what we want. We want the world boundary to be on world, and we don't need it to mask with anything because we're going to have the player interact with the world, not the world interact with the player. It's kind of confusing, but that's kind of how it works. So you just make sure it's on world, and then we're going to run the game with either F5 or F6 or the Mac commands. And you'll see our player will fall, and we can control it with the arrow keys on the keyboard. And you can actually also jump with spacebar. Right now our player is moving a little fast and jumping a little bit too high, so we're going to change some of the default code settings. Under player, you're going to click on their player script again. That'll bring us back here. And up at the top here, speed, we're going to set that down from 300 to 130. And then jump velocity, we're going to change that. Instead of negative 400, we're going to do negative 300. You might be wondering why jump velocity is negative. If we want to jump up, it should be positive. But if you look at the 2D plane here, you'll notice that along the side here, in Godot, Y values go top down, meaning downwards is positive Y and upwards is negative Y. Takes a little bit of getting used to, but because upwards is negative Y, we want jump velocity to be negative as well. We're using these default values of UI left and UI right, and these comments even say that you should replace them with something else. And so we're going to do that now so that the player can use more control options to play the game. So we're going to go to project settings, and then instead of under general, we're going to go to input map. And right now it's going to be blank, but we're going to add some things. So we want a left for the player to move left, we want a right for the player to move right, and we want a jump for the player to be able to jump. But we haven't actually defined yet what those mean. So under left, you're going to hit this plus button, and now Godot is going to be listening for an input. So basically whatever character you hit, that's what character you want to set as left. So of course we want A to be left, and then we'll hit OK. And we'll hit plus again because we also want left on the D-pad to be left as well. You can also go in here, instead of using keyboard inputs, if you want the game to be played by a controller, you have these joypad buttons and joypad axes. And so under axes, you're going to go and find this first one, joypad axis 0, left stick left, joystick 0 left, meaning the left stick on the controller, when you push that left, you're going to move left, which is what we want. Same thing for right. We're going to hit D. We're going to hit right. And we're going to use joypad axes. We're going to select the left stick right to move right. As for jump, we'll keep a space bar. We'll say up on the D-pad or whatever it's called. W also we can set as jump. And then we'll set a button on the controller to jump. We'll set, gotta scroll up here. We'll set button 0 to jump. So that will be the bottom button on a controller. Depending on what controller that is, it's gonna be a different button, but you can add whatever you want here for your game. So now that we've set our controls, we're going to change the code here to reflect that. So instead of UI left, we're just going to do left because that's what we called it earlier. And then UI right is just going to be right. And then up here in UI accept, we change that to jump. Next thing we're going to do is when the player is facing different directions, we want the animated sprite to flip to reflect that. We don't want it facing to the right all the time. And so at the top here, whenever you drag in a node from the side, it's going to create this variable that points basically to that node that you're talking about. So if we drag in the animated sprite, it will create a variable called animated sprite 2D. So down here before move and slide, we'll make a few lines, and we're going to say if direction is greater than 0, meaning the player is looking to the right, we're going to say animated sprite 2D. We're going to use that variable name. We're going to say dot flip underscore h, meaning flip horizontally the sprite. We're going to set that equal to false because we don't want it flipped when you're facing the right. That's the way it's made. Then we're going to say elif direction is less than 0. We do want to flip it, so we'll take this line here and we'll say flip h is equal to true. We also want the idle and running animations to play when these happen. So if direction is greater than 0 or less than 0, we want to play the running animation. So we're going to say animated sprite 2D dot play, and then parentheses, and we're going to play run in quotes, just like that. We're going to copy this same line for direction less than 0, and we're going to say else. If the player is not moving at all, then we just want to play idle. So your code should look something like that. Now if you were to run your game, now we can move around with WASD. We can also move around with the arrow keys or a controller if you wanted. And when we are standing still or playing idle, when we're moving, we're playing run, and we can also change direction. Let's actually start making a level. So let's delete the static body that we created earlier and add a new node, and we're going to name it, it's going to just be a node 2D because it's going to just be a collection. It's going to hold our tile map layers, and so we'll call it tile map. And then within there, we're going to add again and add a tile map layer. You'll see there's this node called tile map. That's the old way of doing it, so you shouldn't use that anymore, hence the red X. Just use tile map layer. Hit create. Then on the left here, you'll see the tile set is currently empty, so we're going to click that and hit new tile set. Click on tile set again. And that'll actually, maybe you don't even need to click it again, because down here you'll notice some new things popped up. Tile set and tile map. Tile set's the first thing we want, because this is what's going to define what our tile set is. And so under assets, under sprites, you're going to find world tileset.png. You're going to drag that right into this blank space here. And it's going to automatically create some tiles. Hit yes. It's very convenient. And then if we drag this up, make some room, there's also the zoom in button. You'll notice here's our tile map, and you'll notice that Godot handled making all the tiles for us. But there is some things we want to change, such as this palm tree here. You'll notice that each part of it is a different tile, but there's never going to be a time when we want to use it all as separate tiles. We want this to be together. So up at the top here, there's going to be this eraser tool. So you're going to select that, and you're going to select the 3x3 grid of the tree to delete all of those tiles. You'll notice it's all faded now. Then you're going to click eraser again to turn off the eraser. And then you're going to click and drag while holding shift. So hold shift, click drag from this top corner down to the bottom right. And now you'll notice that this whole thing just became one tile, which is what we wanted. Everything else we want as individual tiles, so we'll keep those as is. Then we can switch to tile map, and this will allow us to use these tiles and start actually painting the world. So we'll drag this down a little bit just to give us some room. So you're going to click on the tile you want to use, and you're going to make sure you're on the select tool. Make sure you're also on the paint tool. If you want to use like rectangles, you can do that as well. You can use fill buckets, you can do lines. But for now, I'm just going to draw out a basic level. So I'll do a few of these this way. I'll make a little incline here. Maybe I'll take some of this dirt. Make sure you do a bit of dirt below, at least 3 blocks below where the player is, like 3 blocks total here. Maybe I'll use some of this sand over in this direction. Try to create like kind of what I'm doing here, where you have this area where maybe like an enemy can move back and forth in this little gap here. And then over here, let's make some jumps. So we'll add a few platforms, and we'll leave a gap of 3 platforms here and add some tiles there. We'll add these, make sure that again they go down a bit. And then here, let's add this bridge. So if I wanted to, I could like click and drag to select these 3 tiles, and then I can click right here and that'll place all 3 tiles at the same time. You can also add some decorations. So this palm tree that we made earlier, I'll add that over here. So I'll click, add that piece and that piece. And you can even like alternate them, like keep going up like that. And then when you're satisfied with the height, you can add the leaves on top. Same with the tree here. I'll add the stump, and then you can add like 2 middle layers and a top layer. I'll add another really tall one over here in the yellow color. And let's just grab a few of these mushrooms. I'll add a signpost. And I'll add a base over here. So this looks pretty good for now. Doesn't need to be perfect. Again, you'll develop the levels depending on what kind of game you want to make. And just like we did with the world boundary shape, what we're going to want to do is come over here where it says tile set. We're going to click on this to expand out some of the menus. And we're going to go under physics layer. We're going to add element. And we're going to set the collision layer to world, just like with the other one. And we want nothing under the mask section. But unfortunately, that's not it. What we have to do is go under tile set. We have to go paint. We have to select this drop down. We want to paint physics layer 0, the physics layer we just created. And so this is actually going to allow us to paint this collision onto the blocks that we placed. And so all of these blocks we want to have collision. So we're going to click on all of them. Same with these bridges, we want the bridges to have collision. And all of these things we don't want to have collision. These are just going to be decorative. We don't want to collide with the mushrooms. We just want to kind of pass right by them. Same with the trees and the stuff like that. But you'll notice here on these bridges that we did, the collision isn't exactly perfect. And we don't want to hit the bridge down here when obviously that's not where the pixel's showing it is. So let's select this middle one here. And you can use these little nodes to kind of fit the shape of the highlight to the bridge itself. Make sure you don't create any new nodes. If you like kind of click off, it will create a new one. You don't want that. You want to just keep the original for, and now I don't know how to get rid of this one. Okay, you can right click to get rid of it. So once you've made this shape here, it's not actually been applied yet. So you click on the middle bridges to apply it to those. And we're going to apply it to this one here, but these we want to be a little different. We want this to stay where this is because we want it to connect with the middle piece without causing any like jittering issues. So we're going to keep that there. But on this left side here, we're going to drag it up and drag it up. And we're going to paint that on these leftmost 3. And then we're going to click over here to the right side and we're going to do the opposite. And what you can do is you can use this color dropper to select the middle. So now this left side is back to where we want it to be. And then we can click here and then drag this right side up. And again, paint here. And you'll notice that these now form nice smooth collision shapes along this bridge. If you run the game, you'll now see that we can move around on the tiles, and the tiles that we gave collision have collision, and the ones, just the decorative things, don't have collision. But again, you'll notice the player's kind of going behind the decorations, which isn't typical in a game. Maybe that's what you want if you want to hide behind something. But in this case, it's not what we want. And it goes back to that thing I was talking about earlier about draw order. player here is above the tile map, meaning it's drawn first. So you need to actually drag it below, meaning the tile map will now be drawn first, then the player will be drawn on top of the tile map. If we run that once again, now we're going in front of the background terrain. Right now, our camera is very static. It's not moving when the player moves, so it's not actually seeing what's on the edges of the screen here. We want it to move when the player moves. And to do that, it's actually really easy. We drag this camera and we drag it to make it a child of the player. So whenever the player moves, the camera will also move. It's already set to be centered on the character, which is great. So we'll leave that as is. But we do want to change some of the settings. So under position smoothing, we want to enable that so that the camera will smoothly follow the player. Under limit, this will tell you how far the camera can go in either direction. So if the player falls in a pit, we don't want the camera to keep infinitely going down into that pit. So we're going to kind of zoom in here and kind of see where we want this boundary to be. We're going to see probably like -40 is good for my level here. So this bottom boundary, we're going to set to, I'm sorry, not -40, +40. So now the camera won't ever go below that point. We're also going to turn on drag. Drag is a thing meaning if the player is towards the center of the screen, the camera won't immediately follow the player when it's going left or right, only when it starts to get too far off in one direction. You can keep all these settings the same or play around with them however you like. And so if we were to now run the game, you'll notice that the camera will smoothly follow the player. And also, like when you jump or when you move in the middle of the screen, the camera won't follow you because there's no reason to. But as you get further to the edge, it will start to follow and reveal more of the world. Next, we want to add a background to this world instead of it just being a gray blob. And so back to the tile map here, we're going to create a new tile map layer. We're going to go to tile set. We're going to say new tile set, click on it again, just like before. Go to tile set down here. Drag in the world, hit yes to auto create the blocks. And you can use any of the colored blocks down here for your background. Again, make sure you're in click and make sure you're on tile map. And you can click and kind of just drag. Make sure you cover all of these up. And go off a little bit in each of the directions in case the player looks off in that direction. You don't want there to be any gaps. Then we'll add this little transitional layer. If you make a mistake, you can always Control Z or right click to remove tiles. And then here I'm actually going to use this rectangle tool to help me just drag a big light blue blob here. And then once you're done filling in the background, you can drag it actually above here. We want it drawn first because it's the background, and then the foreground is drawn after the background. So we place it in this order, and then we can run the game, and it will look nice and blue now. Next, we're going to add coins. And so coins are going to be an object in the game, but they're not really going to have collision. They're just kind of going to float around. And so when we want just a thing to exist, we're going to use an area 2D. And so again, create a new scene, and then hit other node and search for area 2D and hit create. We're going to call it coin. And when we save it, we're going to make sure we save it in the scenes folder. It's going to give us a similar warning from other objects as before, saying it has no shape. So we're going to give it a collision shape. But once again, we don't actually know what shape to give it yet because we don't have a sprite yet. So we're on the coin, we're going to make an animated sprite. Same as before, go to animation, new sprite frames over here on the right. Click on that sprite frame to bring up this menu down here. Or once again, we're going to be adding it from a sprite sheet. So we hit this button here, coin.png, hit open. And you'll notice here, if we zoom in, it's making this 4x4 grid, which obviously is not what we want in this case. There's only one coin vertical, and there's going to be 12 horizontal. Once we'd say 12 by 1, that will make every coin appear perfectly in this grid, and we'll just click and drag to add all those frames in. We're going to set the FPS to 10, just like we did with the player, to make the coin spin a little bit faster. You can change this to however you want, but if you hit play, you'll see it spins nicely like that. Make sure you go over here and hit autoplay on load. It should look blue when it's selected, and you'll see this little A pointing to default, meaning when the coin is loaded in, it will by default play this animation. Now that we have our sprite in, we know kind of what collision we want, so we go back here, we create a circle, and once again we can drag this to below the sprite so that it covers it, and we're going to shrink it down to about there. That looks right. Make sure you save that, and then just like with the player, to add the coin to the level, we're going to go back to level 1. We're going to find the coin under our scenes folder, and we're going to drag it in to level 1. And then if we zoom in here right at the origin, we can see our coin. And we'll drag it just right there. It looks good. But as we add a whole bunch of coins to our level, it's going to start to get pretty messy over here. So what we're going to do is similar to this tile map node that we created, just as a folder basically to hold these tile map layers. We're going to create a node 2D as a folder, call it coins, and then drag this area 2D coin into that coins folder basically. So now whenever we create more coins, which we can actually do really easily by just Command D to duplicate that coin, now we can have a whole bunch of coins here, and we can collapse this coins folder whenever we need to. These other coins here, I'll actually just use 3 coins, so I'll delete that 4th one that I made. These other 2 I'll drag into position just along these jumps over here on the right side. You can place them wherever you like. And while these coins look good, they don't actually do anything yet. And again, whenever we want something to do something, we need to add code, meaning we need to have a script. So we're going to go back to the coin here, make sure you select coin, and this add script button. Earlier we had a default script to go with character bodies, but most of the time you're just going to get a blank kind of code file. Again, make sure you change this. Right now it wants to save it in the scenes folder, but we don't want that. We want it saved in the scripts folder. And we'll hit create, and you'll notice we get a much more empty code file than before. It's going to give us these 2 defaults, func ready and func process delta. Ready is going to run whenever that object is first loaded into the world. In this case, the coin, we already set the animation to auto load, so we don't need it to do anything else when it loads in. Process delta is going to basically run every frame of the game being loaded. So if the player is running at like 100 frames per second, this function will run 100 times per second. Again, that's not something we need for a coin, so we'll just delete that as well. But what do we want with a coin? We want the coin to do something when it is touched, and so we need a signal to happen of when the player enters the coin's area, something needs to happen. So over here, we haven't discussed this area yet, but next to inspector, there's a node tab. And it doesn't actually say anything right now because I need to click on coin again, make sure coin is selected. And then under node, you'll see all these signals that can happen maybe when the mouse enters it, if you want to hover the mouse over a coin to collect it. But in this case, it's a 2D platformer, so we want the player character to enter the coin, meaning we want this one here, body entered. Body being the character body. Double click on that and it'll ask you where you want to send that signal to. Of course, we want it on the coin, so the default is correct. We're going to hit connect. And that will create our function here. You'll also notice this green door arrow to show that a signal is currently pointing to this function. For now, we're just going to do something very simple. We're going to say in this function, whenever a body enters the coin, we're going to print a string that says +1. This print statement is just going to be going to the output terminal, so it's not something that the player will see. This is just for testing purposes to make sure that the coin is working correctly. But what if an enemy were to enter this coin? We're just detecting for bodies, meaning an enemy body would also trigger this +1 coin, which is not something we want. And so back in the inspector here, under collision, we're going to do this similar thing. Whenever you create a new object, basically, you want to make sure the collision is correct. It's not a player, so we want to just deselect 1, and we want to select 4. It's an item. As for mask, this is correct. We do want it to interact with players, and we don't want the coin to interact with anything else. So 4 for the layer, 1 for the mask. We also want the coin to delete itself once it is collected. We don't want to infinitely be able to collect the same coin. And so under this print1, we're also going to use a function call called queue_free. And that will just delete the object from the game. But we also want the coin to make a sound when the player collects it. So we're going to go over here to this plus to add an audio stream player to this coin node. There's also stream player 2D and 3D that will do like spatial audio, but that's not something we want for this. We just want it to play a coin sound. So we'll just add this default audio stream player. We're going to rename this to collect because we want it to make the sound whenever the coin is collected. Over here for the stream, this is where we're going to put the sound effect itself. So under assets and music, actually not music, under sounds, there'll be coin.wav. So we'll add in that. And if you hit this playing button, it should play the coin sound. But it's a little loud right now, so we're going to set this decibel to -10. And now it'll make a less harsh sound. And to actually play that sound when the coin is collected, between the print and the queue_free, we'll drag this in, this collect, and we'll say .play with parentheses to say we want it to play that sound that it has stored in here. And so we're going to run the game now, but you're going to notice a problem in that the sound doesn't actually play when we collect the coins, but they are being collected correctly. And if we look at this output window here, it is saying +1. So the coins are being collected. Why isn't the sound playing? And that comes from the fact that the sound takes time to play, but we're immediately deleting the coin from existence right after we start playing that sound. And so that's not something we want. We do want to still delete the coin, but we want something else to play the sound, not the coin itself. So on this collect sound node over here, we're going to actually copy this. We're going to go into level 1, and under this coins folder that we made earlier, we're going to paste that. So now the sound is part of this folder. This folder is never being deleted, just the coins are. Under the coin itself, we can now delete this sound because it's being used elsewhere. And this collect call now actually won't work because collect no longer exists as a child of this node. But if we do, after the $, do quotations and then .. and then quotations again after collect, that will now call up to the parent and then down to collect, which is what we want. If we look in level 1 here, this coin, we want to go up to the parent, to the coins folder, and then down to collect. So this call should now work and play the sound. So if we run the game and move, now the sound will play. You'll notice in the debugger here we're getting a warning, not an error per se, just a warning saying that this function parameter is never being used, and it's just standard practice whenever you're not using a function parameter to put an underscore in front of it to signify that it's not being used. Now in our game here, we can fall in this pit and the camera won't follow us, which is good. But what's not good is that nothing is happening and now we're stuck basically. So what we want to do is have some kind of kill zone at the bottom that will reset the level if you were to fall into it. But we would also want it to kill you if you were to step on spikes or something like that. So we want something that's reusable, meaning we want to create a new scene. Think about it intuitively, it's going to be an area. It's not going to be a physical thing, it's just going to be a detectable area that if the player were to enter it, they should die. So area 2D we're going to create, and we're going to name it Killzone. We're going to save this now, and we're not actually going to add any collision to it yet because we want it to be reusable for different things. Like I said, spikes are going to be different from a world boundary Killzone. Don't want to forget to change its collision properties. So over here in collision, the layer we want to set to world because it is part of the world, and mask, we want to mask it with the player, of course. We also do want to mask it with an enemy. Let's say an enemy falls into a pit. We want to kill that enemy and not just have it fall infinitely. We're going to also add a script to the Killzone. Make sure it is saved under the scripts folder. Hit create. And then we're going to see the same functions as earlier, the on ready and process. Again, neither of those are relevant to a Killzone. What is relevant though is similar to the coin, we want something to happen when a body enters it. So we're going to go over here again, make sure you click on Killzone again so it refreshes, and click on node. And then the body entered signal, double click, hit connect. That will give us our function. But when a player falls into a pit, we don't want to immediately kill them. We want to give it a second. And so we're actually going to add just that. We're going to add a timer to this Killzone. Timer is self-explanatory. It's going to count down a certain amount of time, and then something's going to happen when it's done. In the inspector over here, we're going to change it to one shot, meaning it will only run once, and it won't keep repeating over and over. Wait time you can keep at 1 second, that's pretty good. And auto start you don't want to happen because we only want it to start when the player falls into it. We're going to go to node, and you're going to see that timer has a signal called timeout. That's going to play when it runs out of time, which is what we want. So we're going to add that to our script as well. Now, when the player falls into the pit, we want to start the timer so that we can restart the level. If an enemy falls into the pit, we just want to kill them immediately. So we're going to have two different choices based on what kind of body is entering. So we're going to do an if statement for that. So if body.name.contains player, we're going to start the timer. And so we'll say timer.start. If anything else falls onto the spikes or onto the pit, we just want to kill it. So else body.queueFree. Same command as earlier. Now after that 1 second timer is up, we want to restart the level. And there's a command for that. Get tree.reload current scene, just like that. And that will, as it says, reload whatever scene is currently happening. Typically you would want to do some kind of animation or maybe send back to title screen or a death screen. In this case, we're just going to reload the scene to keep it simple. We're now going to add this to our level, so make sure you save. Go back to level 1. As usual, we're going to find our scene, drag that into the level. You can collapse this coins folder because we're done with it now to save on room. And we're going to find this Killzone, and we're going to now need to give it a collision shape. This one we want to be the void when you fall into it down here. So we're going to give it a collision shape, and we're going to set its shape to a world boundary. Again, you're going to make sure the arrow is pointing up, which it is by default, which is great. And you'll just drag it a little bit below the level. Right there, it looks about good. So now if we were to play the scene, we can move around, we can collect our coins, and we can fall into the pit, and a second later have the level restart. Now we're going to add a basic enemy. And so an enemy is going to be just like a player, it's going to be a character body. So again, come over, create a new scene, create a character body. We're going to name it Slime. And we're going to give it an animated sprite, just as we did the player. Over here under animation, make sure you click empty, new sprite frames, click on sprite frames, click on import from sprite sheet. We have this green slime and a purple slime. You can use whichever one you want. I'm going to use this green one. I'm going to hit open and zoom in a bit. Make sure you set horizontal is correct. Vertical is, there's only 3 of them. And we're just going to use this middle row as its walking animation. Adds 4 frames. Keep it at 5 FPS. If we look at it here, 5 frames seems pretty good. We want to set this animation to autoplay, just as we did with the coin. And we're going to drag it up to be on the x-axis as we did with the player. We're now going to give it a collision shape. So we'll go over here, add a collision shape. Again, make sure it's a child of the slime, not a child of the animated sprite. We're going to give it a rectangular shape, and we're going to fit this nice and snug on him. He does move up and down, as you can see, so you can kind of just do whatever feels right to you. If you want to drag it at the top or at the bottom, it's up to you. Now what we're going to do is actually, we're going to set its collision, but we're going to do something weird here. We're going to actually not give it a layer, and we're just going to mask it with the world, not the player yet. This is going to be basically just the hitbox that's going to use to collide with walls and the floor and things. When it hits an enemy, or hits a player even, we want a signal to happen. So we're going to need a new area for that. On the slime here, we're going to add an area 2D. We're then going to give that area a collision shape, and we're going to make that collision shape also a square or a rectangle. And we're going to just make it 1 pixel bigger in each direction so that when the player comes in contact with it, a signal can happen. On area 2D, make sure you come over here to collision, set its layer to 3 for enemy, and its mask to 1 so it collides with players. This area 2D you can rename to hitbox. Then we're going to create a script on the slime. Again, make sure you save it under scripts, which it actually is in the right place. And then you can also use this time to save the slime under the scenes folder. Now this slime script is going to have all the player movement in it, but it's not a player, so we actually want to delete all of that. And the first thing we want to add is the hitbox code. So on the hitbox node, body entered, double click, hit connect. That will get us the function for when the player enters the slime's area. Now what we want to do when the player enters the slime is similar to what happens when it falls in the void. We just want to reload the current scene. But sometimes that can happen like between frames depending on when the player enters the body. So there's actually a thing called call deferred, and it will basically wait for a free time to reload the scene when it's not going to cause issues. So before we do that, actually, we're going to create a new function just called reload, and we'll use that command from earlier, get tree dot reload current scene, and then we're going to call deferred to that function, to that reload function, just like that. And we're also going to add an underscore to body because again, we're not checking what kind of body it is, so this variable is not being, this parameter is not being used. So save that, and then we're going to go back to our level, and we're going to add the slimes in, but just as we did with the coins, we're going to create a folder for enemies first. So make a node 2D, call it enemies. You can drag it up to be closer to where all the other stuff is. Drag in a slime, and we're going to zoom in so we can see it. Again, it's on the origin, and we're going to drag it right into this area that we created for it. And if we were to run the scene, the slime will be there, we can jump on it, and it will reload the current scene. But we want this enemy to actually move, not just stand in a single spot. So we're going to go back to the slime script, and we're going to use a similar function to one we saw earlier, but slightly different. It's going to be underscore physics underscore process delta. Just like process delta, this is going to be running quite often, but instead of every frame, it's going to be 60 times per second. So this will be consistent no matter what the hardware is being used, whereas process will vary from computer to computer. This parameter delta here is the time since the last frame. It's going to be more useful when you're using process because it will vary more, but in this case we're just going to put an underscore because it's going to not be used. Before we do anything in the physics process function, we're actually going to create a variable. To do that, we use the keyword var. We're going to call this variable direction, and we're going to set it equal to 1 to start. It's going to be 1 when the enemy is moving in the right direction, and it's going to be -1 when the enemy is moving in the left direction. Now in the function here, we'll say position.x plus equals 0.8 times direction. So basically this is saying 60 times per second, the enemy will move 0.8 pixels in the direction that it's moving in. But how is it supposed to know when to switch directions? It needs some kind of knowledge of when it hits a wall. And so to do that, we're going to go to the 2D scene, 2D viewer of the slime, and we're going to go on the slime itself, and we're going to add something called a raycast. It's basically going to be an arrow pointing in a direction that's going to detect collisions. Right now it's really long and it's pointing downwards, which is not what we want. We want it kind of pointing in front of the slime, and we want it to be in the middle of its hitbox. So something like that is what you want, where the arrow is pointing out from the enemy's hitbox, so we'll be able to detect a wall. Raycasts have their own collision, and so you'll need to make sure to set this collision mask to world. We want it to detect the world. We don't really care if it hits a player. We don't want to turn the slime around if it hits a player or another slime, just when it hits a wall of the world. Back in our script in the physics process function, we're going to say if the raycast dot is colliding, meaning it's hitting a wall, we're going to set its direction to negative direction. If it's 1, it will set it to -1. If it's -1, it will set it to 1. So that will flip the direction of the slime. If we flip the direction of the slime, we also need to now flip the direction of the raycast so it knows to bounce off of the next wall it hits on going the other way. So we'll say if direction is equal to 1, double equals means comparing it to 1. Raycast dot rotation is equal to 0. Else the raycast dot rotation should be equal to 180. That will flip it around to face left instead of right. We also want the animated sprite to flip directions just like we did for the player. So if direction is 1, then we should say the animated sprite dot flip h is equal to false. And we want that to be true if it's going in the other direction. If we play our scene, we'll now notice that the slime is bouncing off of the walls and going back and forth. And if we stand here and we get hit by the enemy, the level will reset. Now let's add some tutorial text to our level. And so this will be really easy. On the level 1 itself, you're just going to create something called a label. This will just be text. So we'll create, we can call it tutorial. And in the text field here, we can write whatever we want. So we can say, press space to jump. And right now it's going to give us this basic text, and it's going to be a little big. So down here, there's going to be a whole bunch of different settings we can do. Under theme overrides, you can change like the color and the font. This font here, we definitely want to change to something more pixely. So under this font tab in the assets, you can drag in this font, and now it will be pixel font. We also change the font size. If we notice we change it to size 8, it looks pretty good. If we change it to like 16, it looks pretty good. But if we change it to something like 15, it's going to get this blurriness to it. This specific pixel font looks good in multiples of 8. So we're just going to set it to size 8 and drag it kind of right there. Next, what we want to do is add in a global script that allows us to keep track of global variables, such as like a player score. So what we're going to do is we're going to just create the script without attaching it to anything. So in the scripts folder, we're going to right click, say create new script. We're going to call it global. We'll hit create. And then you'll need to double click on it in order to open it up. We're going to delete, ready, and process, and we're going to create a var score, set it equal to 0. Back in the coin script, instead of this print1, we're going to say global.score plus equals 1. But right now, it's going to give it an error because it doesn't know what global is yet. We haven't actually said that this global script is a global script yet. So we're going to go to Project Settings. Then we're going to go to this Globals tab here. And under Autoload, we're going to find the path of our global script by hitting this here, going to Scripts, clicking on Global and hitting Open. And make sure here it's capital Global, and then Add. And now our global is auto-loaded and will always be loaded. We'll close out of that. And then if we just save this, this should now recognize global. Way to get rid of that score when you fall into a pit or get hit by an enemy. So under the Killzone script, right before this reload current scene, we can say global.score is set back equal to 0. And then the same thing in the slime script. Right before the reload, global.score is equal to 0. But currently we have no way of viewing this score. And so we want some kind of HUD on the screen to show us how many coins we've collected. We're going to create a new scene. And this is going to be a canvas layer. I'm going to create that. I'm going to go to the 2D view of it. We're going to rename it to HUD for heads up display. On the HUD, we want a label. As its text, we want to set it to 0 to start. Down here in theme overrides, we'll set its color to yellow. For font sizes, we're going to set it equal to 64. And we're going to change the font to the pixel font that we used earlier. We're going to save that under the scenes folder, and then we're going to add it to the level 1. We'll drag that in. And you'll notice it'll look really big here. I'm not exactly sure why that is, but don't worry about it. It will look fine in the level. If it gets annoying when you're like doing level design, you can always hide it. But for now, we'll keep it around and we'll load the level. And now you'll see this big yellow 0 is in the corner. It's a little close to the corner, so we'll actually, on the HUD, move it inwards a little bit. I think about there looks right. Make sure you save that and then run the game again. And there we go. Now it looks good. But it doesn't actually change when you collect coins yet. Now you'll notice that in the HUD scene itself, we do see this label, but when we moved the HUD into level 1, the label doesn't show up. But we can get it to show up if we want to by right-clicking on HUD here and checking this box that says editable children. And now we can see the label, and that will make it just a little bit easier when we go into our coin script now. We can kind of, we want this label to change, but we need to be able to find a path to it. So first we want to go up to coins, and then we want to go up to level 1, and then down to HUD, and then down to label. And so the code for that is going to be, after we increase global score by 1, we're going to say $, $HUD/label. We're going to say .text is equal to global.score. However, global.score is a number, not a string, and so we do need to cast that to a string in order for us to set the text as that. And now when we save and run the game, and we collect some coins, the number in the HUD goes up. And if we were to fall into a pit, the number will go back down to 0, and we'll start counting up from 1 again. Next, we're going to be adding music to our level, and so at the top here, similar to what we did with the coin, we're going to, on level 1, we're going to add an audio stream player. Let's just drag that up to the top so it's easier to see. Over here is like we did with the coin, where you're going to add the music. So we'll go under Assets, Music, and we'll drag that in. And we can hit this playing button to see what it sounds like. And it's a little loud, so we'll change the decibels to -10. We're going to set this to autoplay so that the music plays as soon as the level starts. And what we're actually going to do is down here, where we got it from the file system, if we double click here, we notice that there's this loop option that we can enable. And because this is level background music, we do want this to loop. So we want to hit enable and then re-import. If you know a lot about music, there is this audio tab at the bottom where you can adjust different buses and have like a master and sound effect sliders and have maybe the player change those with settings in game. But for now, we're just going to keep it simple. When we run our game, you'll notice the music starts playing. But if we were to fall into a pit, the music is then going to restart from the beginning of the track because we're restarting the level that includes restarting the music. So in order to fix that, we're instead going to make the audio stream player its own scene. So to do that, it's actually really easy. We can just drag this right into the scenes folder, and then that will create a new scene with that audio stream player. Let's actually rename it before we do that so that it's not just audio stream player. We'll call it level music. And go ahead and drag it into scenes and hit save. And then we will open it by finding it here and double clicking. And there's going to be nothing here, but again, that's just because it's audio. There's not actually something physical to it. We're going to turn off autoplay now because we're going to have the level call upon playing this. And we're going to go into project settings, back into globals, and we're still under the auto load. We're going to now auto load the music. Similar to the global script, this means that the audio will always be playing, which is good because when we're changing between levels or restarting a level, we want the music to continue playing from where it left off. So navigate to it so it's in scenes, levelmusic.tscn, open, and then hit add. And now the level music is now auto loaded with the global script. Back in level 1, we're going to now delete level music because it's its own scene now. And in level 1, we're going to give level 1 a script of its own. Hit create script, make sure you save it in the scripts folder. Hit create. And now this time we're actually going to use this ready function. We're not going to use process, so we can get rid of that, but we are going to use ready. In ready, we're going to say if not level music dot playing, level music dot play. It's pretty self-explanatory. If the music is not playing, it should play when the level starts. Now when we run our game, the music will play, and when we fall into a pit, the music will continue off from where it left off, and it won't keep restarting every time. Next, we're going to create a title screen, and we're going to use a new kind of node for the title screen called a user interface. It's pretty self-explanatory. We'll call it title, and we can go to the 2D view to see what it looks like. It's going to be like a similar game window as before. And the first thing we're going to add, we'll go through, there's a lot of different kinds of control nodes. There's containers for like sizing, text edit, color, rectangles, just a whole bunch of different kind of panels and user interface things. Under button, there's a bunch of different kinds of buttons. For now, we're just going to use a basic button. And we're also going to add in a label. And we're also going to add in a color rectangle. Color rectangle is self-explanatory. It's a rectangle color. We want to make sure that that is at the top before button because, again, of that draw order, we want the background to be drawn first. Over here on the right, change the color of the color rectangle to whatever you want. I'll make it this like bluish color. But you notice it's very small, and if you look closely, there's this blue outline. The blue outline is what we're going to be able to see, so we want this to match that. And that's going to be the same as the game window that we set at the beginning, which is 1280 by 720. And now we will fill out the entire thing. On our label here, we're just going to give it some text. We'll say game title, whatever you want to call your game. But you'll notice it's very small, so we'll go and do what we did with the other things. Theme overrides, fonts. We'll drag in the bold version of that pixel font. We'll change it to size 100 maybe 64, maybe 128. Make it as big as you want. I'll actually, up here at the top, I'll bring down title onto its own line. And there's a bunch of your usual text settings here, like left alignment we can change to center align. Next, we're going to add a little graphic of our player character. So on title, we're going to add a sprite 2D. It's not going to be animated, it's just going to be a static sprite. And then in the texture, we're going to drag in our knight. So under Assets, Sprites, knight.png, we're going to drag that in. But you'll notice that this is the entire sprite sheet, and we just want one knight. So what we can do is under Region, we can enable Region, and then edit that region. And now this will allow us to size it how we want. And so if we just want this first knight in the top left, we'll just drag it up like that. Then we'll hit close. Then we'll scale him up a bit because he's very small right now. So under transform, we'll scale it by 10. So now it's 10 times bigger. And now we have a little picture of our knight that we can just put on our title screen. Make sure you save your title screen under the scenes folder if you haven't already. And then we're going to go back to this button here, and we're going to say, under the text field, we're going to say start, because this is going to be our start button. It is still very small, so again, we have to go to theme overrides, fonts. We'll drag in the pixel font again. We'll set the size to maybe 32, maybe bigger than that, 64. And there's a bunch of different button settings, but for now, the only one I'm going to have you change is under mouse. You're going to change this default cursor arrow to pointing hand. And that's basically going to make it so that when you hover over the button, it changes the mouse cursor to that pointing hand. Makes it clear that this is a button you want to press. You can also change the size of this button a little bit to allow more breathing room between the text and the edge of the button. I think that looks good. On the left here, this button, we're going to rename it to Start Button. And then we're going to add a script onto the title screen. Make sure it's in the scripts folder. Hit create. We're going to get rid of these two defaults. And we're instead going to say, when this button is pressed, we want to load into level 1. And so that is going to be a signal, just like earlier. So we click on Start Button, we go to Node, and we have this pressed signal. This will emit a signal when the button is pressed, which is exactly what we want. So we're going to connect that to the title screen. And then when that button is pressed, we're going to run getTree.change scene to file, and we're going to change that scene to level1.tscn. So this is what you want it to look like. getTree.change scene to file, res/scene/level1.tscn, like that. But if you remember earlier, we made our default scene level 1, and now that we have a title screen, we want to make the title screen our default. So we're going to go Project, Project Settings, under General, Run, right at the top. Here's our main scene. We're going to hit this little swirling icon to say reset that to default, which the default is nothing. Then we're going to close. And then if we hit this Run button here, it will ask us once again, what do we want to make this our default scene? Make sure you're on title screen, and then we'll select current. And now the title screen is our default scene. And if we hit the start button, that will bring us into level 1, and the music will start playing. Now we're going to talk about exporting the game. So the first thing we need to do is get export templates, which is going to be under the editor settings. So under editor, go to manage export templates, this second one from the bottom. You'll probably see something like this: export templates missing, download or install them. Make sure it's best available mirror, and then you hit download and install. And once it's in downloading, you should see export templates are installed and ready to be used. So we'll hit close. Then we're going to go up to Project, Export, and we're going to add a preset. The first one we're going to do is for Windows. Under Export Path, find a place where you want this game to be saved. I have it saved into a folder on my desktop currently, and I'm calling it game.exe. Next, you want to click this checkbox next to Embed PCK, turn that to on. Then we're going to click Export Project. It'll once again bring up this menu. Make sure you call it whatever you want to call it, .exe. If you want to export it with debug, you can. Otherwise, you can check this box off and then hit save. You'll probably get this warning about RC edit. That's for the icon of the game. It's not important right now. And now the game has been exported, and so this will be an exe. If you're on Windows, you can just double click to run it, and it should bring you into the title screen. Next, for Mac, you do need to be working on a Mac in order to export for Mac. But if you are, then you can add macOS. Same thing here, find an export path. Under bundle identifier, just make up something like com.gamename.game. And depending if you have like an Apple developer's license, you can do some things here, but if you don't, just use built-in, the ad hoc only. And we're getting this warning down here about some kind of texture format is disabled, so we're going to go find this. Under general settings, under rendering textures, we will check this bottom one here. And then click save and restart. Back into our export settings, we'll notice that we'll get these yellow warnings, but there are no red warnings anymore, which is good. So we'll hit export project. Again, make sure it's in the right place. You can decheck debug and hit save. Now where I saved it, I'll have this game.dmg. I can double click on that. This will open up a driver, which then I can double click on this. And that will launch us into our game. The final kind of export we're going to do is for WebGL. So we're going to go here, web. This will allow us to play the game in a browser window. Make sure, as usual, you select the correct export path. And this is very important. You're going to want to call it index.html. You can't call it anything else. Make sure the file name is index. We're going to keep all the other settings the same, so we'll hit export project. Again, index.html, export with debug, you can decheck and hit save. You'll notice that this will create a lot of different files in the folder. This is expected, and this is what you want. Next, you're going to want to compress this to a zip file. So on Mac, you're going to right click and say compress game. On Windows, it should say something like compress to zip. And now you'll get this zip file with all of those things inside of it. Now to upload your game to a website like Itch or any other website that supports browser games, you're going to go to upload new project. You're going to give it a title. I'll say tutorial game. This will create a URL that you can modify a little bit. If I don't want that hyphen, I can just call it tutorial game. Here's where you can upload a cover image, which you should definitely do if this is an actual game. In this case, because it's just a tutorial, I'm not going to do that right now. Short description, tutorial. It is a game. It is not a game asset or a mod, so I'll leave that as is. It is going to be downloadable, but it will also be HTML, so I'm going to switch it to HTML. You can set that. If your game is just going to be downloadable, you can set it to that. Over here, you can also add a YouTube link or screenshots to advertise your game further. I'm going to say that this is a prototype, but if this was in development or released, of course, set it as appropriate. For pricing, I'm going to set it to no payments. Here's where you're going to upload your game files. So hit upload, navigate to where you have them saved, and we're going to click the three of these. We're game.dmg, game.exe, and game.zip. We're going to upload those. You can reorder them how you want, so I'm going to move the zip file, which is our browser version, up to the top, and I'll move the Windows version above the Mac version. Make sure you select these as appropriate. Game.zip here, we're going to say this file will be played in the browser. Here for viewport dimensions, we're going to change that to what we set it at the beginning, which is 1280 by 720. Down here, you can check this full screen button and any other buttons that you want to select for your game. For our community, because this is just a prototype, I'm going to click disabled so that people cannot leave comments. And I'm going to keep it as a draft so that no one can view it right now. Except me, of course. So I'll hit save and view page. It will load the game. We can click on run game. And now we can play our game in our browser. Or you can scroll down and download the exe or the DMG files from down here. And that's going to do it for this tutorial. If you have any questions when you're making your own games, the docs for Godot are very good at docs.godotengine.org. This will tell you about every kind of node and a lot of different function calls. It's a very good resource. I hope this has made you guys more interested in learning Godot and making your own games. Have a good one.